Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so let's consider trig, and let's consider some sine waves and cosine waves. Okay, so as you know, most functions have a general form. So for example, probably the one we know best is the quadratic equation ax squared plus bx plus c is equal to 0, cubic equation ax cubed plus bx squared plus cx plus d is equal to 0, and so on and so forth. Okay, so lots of things have general form. Is there a general form for a trig equation? Well, yes, there is. Okay, so a plus b sine cx, or of course a plus b cos cx would be the general form of a sine wave or a cosine wave. Tan is a little bit different because it's not a continuous signal, so I'll park that one for now. But this is the general form of a trig function. Okay, so when you graph it, and apologies for the graphing now because I have no rulers, so it's freehand. Okay, when you plot a sine wave always starts at 0, amplitude of 0 at 0. Okay. Yeah. Okay, and imagine that's symmetrical about the x-axis. Okay, so that is a sine wave. From top to bottom, peak to peak is your range. Okay, the time it takes to complete one full cycle, so up, down and back again, one full cycle is your period of your waveform. Your period and your range, yes. Okay, so what do these, how does it tie into these? Well, this letter B here is your amplitude, which will give you your range. This number C here is the number of cycles in a 0 to 360 degree window, okay, or 0 to 2 pi window. Okay, so when we're considering a sine wave, as you probably know, there's 360 degrees in an entire rotation. Okay, if I go back one, for anybody familiar with wind turbines are one way where waveforms are generated, because actually power coming into your house comes in as a sine wave, a cosine wave. So it's generated by wind turbines, okay? And the wind turbine rotates anti-clockwise, okay? So one complete turn of the wind turbine equates to one cycle of your wave, okay? So it starts here at 0, which corresponds to here. It goes anti-clockwise, so after a quarter of a turn, it's at 90 degrees. It goes all the way around, does one turn. Here, it's 180 degrees. So you can see you're here at 0. It then goes down to minimum, down to 270 degrees and back to 0. Okay, so that's what's happening, the wind turbine and so on and so forth. So one full rotation of a standard sine wave is 360 degrees. So when we're talking about a window and trig forms, we're normally looking at, well, what happens in a 360 degree window? Okay, you can have more than one rotation in a 360 degree window. So for example, here I've drawn 2. Okay, so for the purposes of maths, I'm going to put 360 degrees there. Halfway is 180 degrees. Okay, and then just to explain some of the numbers, I'm going to put 3 there and minus 3 down here. Okay, so how would I describe the waveform I have drawn here? Well, I would say that that waveform, f of x, for example, equals, I never explained what this a is. So this a is an offset. Okay, in many cases, our trig functions circle around the x-axis. Okay, so there's no offset. This is 0. Okay, but in some questions, if you've done exam questions, such as a boat is floating on water, then the water is obviously going to be up here, or yeah, various things are happening. You can't hit off the bottom of the port, for example, so everything is offset. Okay, so in this case, your waveform is not circling or is not rotating about 0, it's rotating about a value up off the ground. Okay, so in this case, this one would have an offset called A, so it could be 2 plus sine 2x or whatever. Okay, this one, I've got no offset, so I have no A. Okay, so I hope that makes sense. That's where the offset comes into it. And like I said, we'll do questions on all of this. This is just, I suppose, the background to it. So your B then is your amplitude. So my amplitude is 3. Okay, it's a sine wave. How do I know that? Well, you put 0 degrees into your calculator and go sine of 0, and you'll very quickly get 0. If you put cos of 0 in, you'd see a cos wave actually starts at 1. Okay, so it's a sine wave. I've got 2 rotations in my 360 window, so it's 2x. Okay, so that's that particular function. So A plus B sine cx. Okay, what is the period of that waveform? So period, you need to learn off. It's the time taken for one full cycle. Okay, so it's 180 degrees. Okay, or there's a formula for it. It's 360 degrees, so it's that window that I talked about divided by C. Okay, which is the number of cycles in a 360 degree windows. So you can see then if there was 3 cycles in that window, your period would be 120. So that's your period. My range in this one is -3 to 3. Okay, you can also see this from B. Okay, and that's all I can think of for recognizing trig functions. So I'll come back to that again with questions in due course. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.